Okay, folks, I think this might be the last one, so this one should be pretty short. We are multiplying monomials times polynomials using the distributive property. So, like I said at the end of the last section, this one is actually backwards, and it has multiple variables. So, our four-step process for multiplying monomials by monomials is still going to be a four-step process, but there's going to be more parts to each step. But first, let's start by distributing. So we're going to take that and multiply it by that, and multiply it by that, and multiply it by that, and then multiply it by that. So let's write these out as our monomials times monomials to see what it looks like. So it doesn't matter what order I write them in, so I'm going to start with what comes first visually. 21ab cubed times a squared b plus 5ab squared times a squared b minus 3ab times a squared b minus 7 times a squared b. Okay, next step, group our coefficients together. This one actually turns out to be pretty well because our monomial has a coefficient of 1, so our coefficients are going to just be basically stay the same. But let's group all the other variables together as well. So I'm going to have a 21 times a squared times b cubed times b plus 5 times a squared times b squared times b minus 3 times a squared times b minus 7. Well, this one, we don't have any other variables to combine. This one is actually done. 7a squared b. Okay, so we've got done our variables. Now let's use the product of powers property to figure out what the exponents for each of our variables are going to be. So we've got 21, and then a to the first times a to the second is going to be a to the third. B to the third times b to the first is b to the fourth, plus 5 times, whoops, don't need that, 5 times a to the first times a to the second is a to the third, and then b to the second times b to the first is b to the third. Then minus 3, a to the first times a to the second is a to the third, and then b to the first times b to the first is b squared. And then we have the last term here, which is really beautiful. Okay, so that's basically it. That's our new polynomial. We had a 4-term polynomial to start with, and we ended up with a 4-term polynomial. Let's see if this is actually in standard form. So let's kind of just look at the degrees of these terms. This one is a degree 7 because of 3 plus 4. This one, 3 plus 3, is degree 6. This one here is 3 plus 2, so it's degree 5. And this one here is 2 plus 1, so we have a degree 3. So it does look like it is written in standard form, and we are golden. So this is our final result. 21a cubed b to the fourth plus 5a cubed b cubed plus minus 3a cubed b squared minus 7a squared b. So just a few steps. When we write them all out, with more practice, you'll be able to do it in one step. So I promise you that. It is not very difficult once you have the practice. Okay, so We have one more example here, and it's a geometry one. This is actually one that's kind of complex, and I was thinking about doing this one in breakouts because there are so many different ways that you can actually approach this one. I'm actually going to, I think, give myself a little bit more space here. Only because there are so many different ways to do it. I'm kind of going to start out with, I think, what might be the most straightforward way. So we want to write a polynomial that represents the area of just this shaded area. So it's that and that. Okay. So one of the ways to look at this one is I'm kind of looking at this as a rectangle with a triangle cut out of it. So I'm going to work on finding the area of the rectangle, just call that area of the rectangle, minus the area of the triangle. So we need to know what those formulas are. Area of the rectangle, I'm going to call it base times height, because the area of the triangle is 1/2 times the base times the height. So how would we write the area of the rectangle? Well, our base is x, and our height is x minus 8. Then the area of our triangle is 1/2 times the base times the height. So this isn't too bad, actually, because once we have x times x minus 8, we use it twice, so we don't really have to figure it out twice. So distribute. So we've got x squared minus 8x, then minus 1/2 times, let's distribute, x squared minus 8. So let's see, x squared minus 8x. Now we have more distribution to do. We have a negative 1/2 that we have to multiply through. So negative 1/2 times x squared is negative x squared over 2. And negative 1/2 times negative 8 is plus 4. Now let's start combining our stuff. And I know this thing, this x squared over 2, or this 1/2 x squared, we don't like that, but let's group our x squared terms together. That way we can do all of our x squared stuff together, then our x stuff, and then our constant. Does that look right? X squared, this should be 8x. There should be 4x. There should be 4x. So sorry about that. Yes, it should. Okay, cool. So here we have a situation where we're subtracting a fraction from essentially a whole number. And since it's a half, it's kind of easy. If we have a whole of something, and that something happens to be an x squared, and we take away half of it, we're going to have half of it left. So we're going to have x squared over 2. If you want proof of that, let's get that common denominator there. Multiply that top and bottom by 2. So then we would have 2x squared minus x squared, which gives you x squared over 2. And now we can work on this. negative 8 squared plus 4 squared. That's negative 4. I'm sorry, I'm saying the wrong things. Negative 8x plus 4x equals negative 4x. So that's our area of that shaded section. 1/2 x squared plus 4x. Not quite as complicated as you might think. If you take each part and break it down, then you can work them together. And that's kind of the secret of everything mathematical. You want to break things down, see how they relate to each other, see if you can find patterns, and see how you can recombine things. So, it's kind of like puzzle. There are other ways we could have approached this. Definitely. We could have, let's say, split the whole thing in half and only worried about half of it, like cut it down that dotted line. And then at the end multiplied by 2, since we have 2 pieces. We could have done that. We could have found the area of one of the triangles and then doubled it. So lots of ways, but I think this way is probably the most straightforward and the easiest way to see it. So to end this up, I want to talk a little bit about this. This is actually, I really like this quote from Lincoln. It often requires more courage to dare to do right than to fear to do wrong. And we talked about this a little bit. Sometimes it's really hard to do the right thing. And sometimes it's harder to do the right thing than it is to do the wrong thing. And it's kind of strange because it's kind of almost the opposite of math. I usually worry about this fear of doing something wrong. And I would much rather people have the courage to end up doing something wrong. I would so much rather see you guys try and not be successful than not try and give up. So that's kind of my thoughts on this. So that's the end of this lesson on multiplying with monomials. And we will finish up another lesson very shortly.